Hey guys, welcome to your next lesson and your next unit. Today we're going to start talking about describing a relationship between two quantitative variables. We just finished up a chi-square unit in which we talked about one of those tests was the chi-square test of association, where we were looking at the association of two categorical variables like gender and study habits, right? Gender, male or female, study habits, good study habits, hardly studies, those are categorical variables. So we looked at the association between those types of variables. But we're going to now take a look at the association between two quantitative variables. And this is going back to chapter 3 in our text. So we'll start with this scenario. It says, is there a relationship between the number of turnovers an NFL team has and the number of points they score? Okay, so I know a lot of you are familiar with football. You know what a turnover is. For those of you that don't, a turnover is basically when you give the ball away to the other team, either via a fumble or an interception. So maybe you drop the ball on the ground and the other team picks it up, or you throw the ball to the other team. These are both bad things, right? Because if you have turnovers, it does two things that are bad. One, it prevents you from scoring. And two, it creates opportunities for the other team to score. We're going to focus on the first of those today, though, and that is how it prevents us from scoring when we turn the ball over. So when we're going to do this, we'd like to build a scatter plot. That's the kind of statistical plot we use when we compare quantitative variables. It's called a scatter plot. So that's what we're going to build here, this idea of a scatter plot. So we've seen many types of statistical graphs. The scatter plot is the graph we use when we compare to quantitative variables like we're going to do here. Now, when we build a scatter plot, it's helpful if we can identify which variable is what we call the explanatory variable and which variable is what we call the response variable. So the first one I mentioned was this explanatory variable. And the other was this response variable. So let's talk about what these are. An explanatory variable, well, you can see the word explain in the word explanatory. So the explanatory variable is going to be the variable that kind of explains the other, and the response variable is the one that responds to the other variable. So if we can, and we can't always do this when we're doing a scatter plot comparing quantitative variables, but if we can do this, we will. We'll try to identify which one's explanatory and which one's the response variable. In this case, does it make more sense to say the number of turnovers explain the points scored, or does it make more sense to say the points scored explain the number of turnovers? And I think it's the first of those two that makes more sense. So we're going to say the explanatory variable for our scenario that we're looking at here is going to be the number of turnovers. Because we're thinking, okay, it kind of makes more sense to think of it that way. The number of turnovers help to explain the number of points a team is going to score. So that's our response variable, is the number of points scored. So when we're looking at this relationship, we're saying, okay, the turnovers might help explain how many points a team scores. And we might think that if you turn the ball over more, you're going to score less. That's the relationship we're anticipating here, I think, right? If you're giving the ball away to the other team, you're going to prevent yourself from scoring. So the more turnovers you have, the less points you're going to score, we think. So let's see if that relationship comes true or turns out to be true when we make our scatter plot. Now, once we decide which one's the explanatory variable, that's the one we want to put on the x-axis. And that's easy to remember, explanatory variable, x-axis. So the number of turnovers is going to be here. So the number of turnovers is the explanatory variable, so that's going to go on the x-axis. The response variable is points scored. And one of the things you're probably familiar with from prior math courses is that on the x-axis or the horizontal axis, that's where we usually put the independent variable. And on the y-axis or vertical axis, that's where we put the dependent variable. So this depends on this. So this point scored responds to this, or this explains this. So explanatory variable, x-axis. Okay, so how do we build the scatter plot? Well, you've printed out the data for these NFL teams in the 2020 season, and they're in alphabetical order. The first team on the list is Arizona Cardinals. So they had 21 turnovers this year, and they scored 410 points. So 21 turnovers, so we find that, and then we go up to 410 points scored, which is somewhere here-ish. So I'm going to put an X there. You can use dots or X's. So I'm using X's here. The next team on the list are the Atlanta Falcons. 18 turnovers and 396 points scored. So 18 turnovers and 396 points scored. So that's about here-ish for the Atlanta Falcons. The third team on the list, the Baltimore Ravens. 18 turnovers and 468 points scored. So 18 turnovers, 468 would be somewhere like here-ish. All right, so that's the first three teams. To build a full scatter plot, we got to plot 29 more points. So what I'm going to do is I'm going to pause the video now. You should do that too so that you can create your own scatter plot based on the data. So I'm going to do it too. So let me pause the video, and when I'm unpausing it, that's when you'll see the full scatter plot here. So I encourage you to do the same. Okay, so these are what the 32 points should look like here. Now remember what we said. We said the more a team turns the ball over, the less they'll score. And I think we're seeing that here, right? It's not a perfect association, not by any stretch. But we do see the general gist of these points going in this direction, this negative relationship, which makes sense. The more you turn the ball over, the less points you score. Now, when we're describing a scatter plot, there are 3, maybe 4 things that we're supposed to talk about. So let's talk about that. So we're going to say when describing a scatter plot. So when describing a scatter plot, we want to discuss the following 3 things. And that is direction, form, strength. So those are the 3 things we want to discuss: direction, form, and strength. Now there is one other thing, and we always kind of consider this, so I'll add it in parentheses here, and that's outliers. By the way, your textbook has another acronym here that they like to use, and that's DOFS, D-O-F-S. So if you want to use that as a mnemonic device, direction, outliers, form, and strength. So direction, form, and strength, and yes, we always look for outliers. That is true. But we definitely want to describe these 3 when we describe a relationship. So I am seeing a relationship here. Now, what's the direction of it? Well, it's a negative relationship, right? As these numbers get higher, these numbers get lower, right? So it's going to be a negative direction. So I already know that I'm going to describe the direction as negative. Now, when it comes to describing the form, usually it comes down to either linear or curvy, right? And for our purposes here, I think this is pretty much linear, right? Again, it's not perfect. And I suppose some can argue that maybe it's a curvy relationship here, but we're just going to go with the linear relationship here. And I'm going to say, okay, this is a negative linear association. I can kind of see a linear trend in this. So I'll describe this form as linear. Now the strength, obviously it's not very, very strong. It's not even moderately strong. But I would say, yeah, there's a moderate relationship here, moderate to weak, right? So we usually either describe it as weak or moderate or strong or some variation of that, moderately strong and so on. So we would definitely not describe this as very strong. We wouldn't describe it as strong. At best, we would say moderate or moderately weak. I'll just go with moderate here as that description. And in terms of outliers, I do see 2 points that don't follow the trend of the other points. And that's important to realize here. So specifically, when we use the phrase outlier in a scatter plot, Outliers are points that don't follow the trend of the other points. And the trend that we're seeing is this linear negative trend right here. And most of the points are within that linear band, if you want to consider it that, like a band that's like linear going like this. But there are a couple of points that don't follow that trend. Now, before I identify those 2 points, I do want to mention this, that let's say there was a team that had like, I don't know, 40 turnovers this year. So that would be like out here somewhere. As long as they scored, let's say, about 200 points, that wouldn't necessarily, so if I'm out here, that wouldn't necessarily be an outlier to us because it's following that trend, right? If that team was like up here, then okay, definitely an outlier. But since it follows the trend, even though maybe it had way more turnovers, it's not really considered an outlier because it follows the trend. But there are 2 points in this graph that clearly do not follow the trend. And that's this point here, right? It's really kind of not along that path, that negative path, and this point right here. And as we know in statistics, outliers are always interesting. This team up here is a team that scores a lot more than we would expect for a team with that many turnovers. So if you have about 22 turnovers, you should be scoring about 400 points. But this team was scoring 500 points. So this team must have an outstanding offense, given that they turned the ball over a medium number of times, like kind of in the center, but they scored a ton of points. So this outstanding offensive team, Buffalo Bills. On the opposite side of things, we have this team right here, who also were kind of in the center for turnovers, actually a little less. They had probably less than the average number of turnovers at 19 turnovers. But at 19 turnovers, they should have been scoring, in the neighborhood of just under or about 400 points, let's say. But they scored way less than 300. So it looks like 250 or barely 240 or 250. So this must be a woefully inept offensive team. So it should come as no surprise that this team is our beloved New York Jets right there. So as we said, outliers are always interesting. Now, back to this. When we describe direction, form, and strength, it's not good enough just to say negative, linear, moderate. Because what's missing there is the context. And we know in our course, we have to talk about context. If you just say, I see a negative, linear, moderate association, you'll get virtually no credit for that because you're not talking about football teams. And we have to talk about that here. So when we're doing this, right, we want to write something, a couple of sentences that describe direction, form, and strength. So we'll say there is a moderate, I guess you could say moderately weak, but we'll go with moderate. There's a moderate negative linear, so I have all 3 of those adjectives in there describing strength, direction, form. So there's a moderate negative linear association between number of turnovers and number of points scored. For NFL teams. So yeah, we do have to talk about context when we're addressing direction, form, and strength. So there's a moderate negative linear association between number of turnovers and number of points scored for NFL teams. And you can do one better than that by adding maybe a sentence, I don't think I can fit it in here, that says, yeah, as a team turns the ball over more, they have a tendency to score less, right? So that would be a nice sentence to add to this. But since we should talk about outliers when we see them, we could add to this as well, and I won't write this either, but this would also be something we would want to address. We would say we note 2 outliers, 2 points that don't follow the trend, and we can say the Buffalo Bills score a lot more points than we expect for a team that has about 22 turnovers. And the New York Jets score a lot less than we would expect from a team that has 19 turnovers, right? So we would address that too. I just didn't have time to put it in there and squeeze it in. Okay, I do want to show you next how we can build the scatter plot in our calculators. So that's coming your way next. Okay, so I'd like to show you how you can build the scatter plot that we built here by hand with your calculators. So first thing you have to do is get the data in the calculator in the lists. So you hit Stat Edit. Notice here I've put all of the turnover numbers in L1. In L2, these are the points scored. And in L3, I actually have the points given up. First, let me show you how we can duplicate this using the data in the first two columns here, L1 and L2. So once you have the data entered in there, you go to second and then stat plot, which is above y equals. And what we'll do is, let me move out of the way here. What we'll do is we'll turn on plot one. So I'll hit enter. I'll turn on this scatter plot. And the very first choice, that is the scatter plot, the one with all the dots there. So I'm going to choose that. My X list, that's my explanatory variable. That's my turnovers. I put those in L1. So I'm going to keep my X list as L1 here. And then the Y list, those were the number of points scored. So that is in L2. So I'll leave that L2 there. And what else do we got here? Oh, well, you can choose the mark that it's going to use and the color. I guess I'll stick with this mark with the blue color, I guess. And as we know, there's a zoom in the calculator that's just specifically for statistics, and that's this number 9, zoom stat. So I'm going to choose that zoom 9. And when I do, it should give me a decent picture of the scatter plot. So there it is right there. And, basically this picture that we drew here. You can see that negative trend in the data in the scatter plot. You can see the two outliers, the Buffalo Bills up here and, the Jets down here. So that is the negative association that we see. Again, it's not very strong. It's not even strong, right? It's moderate. You could even say moderately weak. But, there's definitely a negative relationship there. As you have more turnovers, you're going to score less points. That makes sense. But now I'd like to take a look at another scatter plot, the one that compares turnovers to the amount of points that you give up. Because like I said at the beginning, turnovers are bad for two reasons. One, the more you turn the ball over, it prevents you from scoring. That's what we looked at. But when you turn the ball over, it also creates more opportunities for the other team to score. And usually announcers at football games always talk about that one, right? Like when you turn the ball over, it's like, oh, they're going to score points. You turn the ball over to the other team. So let's see how strong that association is. Now, before we look at it, let's predict, is it going to be a negative association or a positive one? So the more you turn the ball over to the other team, the more they're going to score, right? So that should be a positive association. So when we look at that scatter plot, instead of seeing a negative association like we see here, we should see a positive one. Let's see if that happens. So I'm going to go to second stat plot here and plot 1. And instead of using as my Y list L2, I'm going to use L3 because that's where I put the number of points given up, right? In other words, the number of points the other team scores. That's in L3, so I put those numbers in L3. So we are expecting a positive association this time. So I'll hit zoom 9 again, and this is what we see. Now, it's hard to pluck out a positive association here, right? It almost looks like there's no association here. I guess maybe there's a slight positive. I don't know. But this is interesting, and this happens every year. Clearly, there's a stronger association between turnovers and the prevention in the points that you score as a team. That's a stronger association than the association which is the more that you turn the ball over, the more the other team scores. We barely see a positive association here. It's hardly even there, right? Which is kind of surprising, right? But this always happens. And when I look at this data, I'm always kind of surprised myself, but it happens every year. So it looks like if you turn the ball over a lot, it's bad for two reasons. It prevents you from scoring. It also creates opportunities for the other team to score. But it seems like the one that's more closely associated with turnovers is the one where it prevents you from scoring.